Okay, we've talked about a lot of things in this first section here, the evolutionary consequences for dinosaurs, their geological conditions, their environments, geologic time, what fossils are, all kinds of things. But now let's actually start talking about dinosaurs. And where you have to start right away is, well, where did they originate? Where did they start? So we know that they once lived on Earth. We know that they evolved via natural selection, etc. Where did it, where is it? So the first method we use to find the oldest dinosaurs is simply to go to the oldest rocks. Remember that geologic time scale. We need to go to Triassic aged rocks around the globe and start looking. And that's literally what paleontologists do to find these things. They go to Triassic age rocks, and remember we have this time scale to tell us what's Triassic and where, and then they start looking. And the dinosaur fossils that are going to be in the lowest layers worldwide is going to mark the place where we have the origin. Okay, don't worry so much about this whole notion of is this a cladogram or a tree. This is an evolutionary tree, and this shows where we think these things started and worked at. So below this would be the early Triassic. We have no evidence of dinosaurs in the first part of the early Triassic. In the middle Triassic, we have a few places where we find some bones of something. It's hard to tell what they are. And then some tracks. So dinosaurs probably existed in this middle Triassic, but we just don't know for sure. And then we finally get into the late Triassic, and then we have, boom, the two major types of dinosaurs right off the bat. I haven't talked about these yet. I'll do that next week for week 2 to talk about Saurischia and Ornithischia, but suffice it to say that right off the bat, boom, we find fossils of the two major types. It means that they almost certainly had to have existed earlier. We just haven't found fossils of them. And that's actually good and exciting because what it means is that paleontologists can always say, I need more grant money to go here. I need to spend more of my lifetime looking for these fossils in this or that place. And you have a small army of paleontologists going around the globe trying to say, hey, dude, I found the oldest dinosaur. Right now, the oldest dinosaurs are found in what today is South America. Now, here's a map of the world during the early Triassic, and this is still Pangea time. Notice all the continents are together. There's one giant continent and one ocean. Now, all of this is going to split apart and break apart eventually and move to the map that we know today. So that's going to create, so that's geology creating barriers. But the oldest rocks that we have that have dinosaurs come from South America. And what do we have there? We have a cute little dinosaur called Herrerasaurus, a small little thing in dinosaur terms, 3 meters or so, 6 meters for some of the bigger ones here. And there's a couple others there. This Eoraptor is much, much smaller one. And so this is a late Triassic dinosaur. Look at those numbers there, 227.8 plus or minus 0.3 million. Again, we can attach numbers. We know how to do this, but we're not really going on to this in a big way in this course. So if we want to say, well, what's the oldest dinosaur currently? It's those two. Let's just say Herrerasaurus, but also this little thing, Eoraptor. What about in North America? Well, that goes to Coelophysis, and this is a little organism, again, less than a meter in length to a few meters in length, that has been found in great numbers, over 100 skeletons in New Mexico. And this was a carnivorous dinosaur. Everything we see in the bones of this thing says that it had a mouth full of steak knife teeth and was, basically a ferocious carnivore of its day. What about the environment? It's found in ancient river environments, so the bones are a scattered mess, but we're able to reconstruct hundreds of these things like this. What What about some other early dinosaurs? The Triassic is very, very well exposed in Germany, and there's an early diagram or an early fossil there called Plateosaurus, and this one's rather large. This can be up to 10 meters, a meter being a little over 3 feet in length. This one was clearly an herbivore, so not an organism that ate meat like these other things. So the early North American Coelophysis and the early South American Herrerasaurus and Eoraptor were clearly carnivores, but this thing was a slow, methodical herbivore. So we're getting this diversity of types. Look what's happening. We have dinosaurs all over this ancient Pangaea, so all over the globe. We have dinosaurs of many different types of groups. It's an interesting way to think about it. As soon as we start finding dinosaurs on planet Earth, they're already diversified into a whole bunch of things. That makes us say that we need to look for more. It's a very wordy list over here, but let's just say it's this. So from the late Triassic, from about 228 to 220 million years ago, we have 10 different species. All these different words here just suffice it to say that we have lots and lots of different species of lots and lots of different types. Anytime a paleontologist would look at a slide like this, it's complex, and sometimes for non-paleo people it's hard to understand. But in a nutshell, like it says here, those are all the different dinosaur species that we have found in the Triassic. Right at the beginning, the earliest spot, we have 10 different species, and then more. And it's going to be more and more and more. And so what this means, these earliest dinosaurs, as far as what we're finding, have already diversified. So there has to be an earlier history that we just haven't collected yet. Great news for anybody that wants to be a paleontologist. That's the frontier right there. Find the earliest ones. Find the true origin of these things. This is going to be the end of this first part, this week 1 for this Winterim dinosaur class, where we've covered a lot of the conceptual stuff. You've learned a little bit about geologic time, evolution, tectonics, origins, etc., etc. Now the next week, first of all, you're going to be tested over this, but then the next section that we're going to have are our discussion of all of the different types of dinosaurs. So, it's coming. After this next test, we talk dinosaurs.